Hello and welcome to Startup Hack. Today we are going to discuss about 10 rules for writing asynchronous code in C#. So let's get started. So today's agenda is number 1, do not use async void. Number 2, use value task or task.fromResult for easy computations. Number 3, use await instead of continue with. Number 4, task.wait async or over task.delay. Number 5, use new thread instead of task.run for long running process. Number 6, do not use task.result or task.await. Number 7, always pass down cancellation tokens. Number 8, do not use action parameter alone. Number 9, flush streams before disposing. And number 10, do not directly return tasks in async functions. So let's dig in.
Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started.
Alright, imagine if you are a chef in a kitchen full of ingredients, some fresh, some a bit past their prime, all thanks to Microsoft's "we never throw anything away" policy. This is what programming asynchronously in C# is like, an overwhelming mix of new and old syntax all in one big pot. This pot can turn to be a big ball of code mud. You could end up with the coding equivalent of food poisoning, thread starvation, deadlocks, or even the dreaded application crashes. Most of these problems boil down to a lack of understanding of the underlying concept, such as state machines, the thread pool, context switching, etc. So in this video, I will show you simple 10 rule cookbook. Here as are those pretty common in the industry. There's a lot more than 10 rules. Feel free to let me know if you want the rest. Alright, let's start with the first rule. Do not use async void. From all the rules, this one is the most critical, potentially crashing your whole application. Async void can't be tracked, and if any exception is triggered, it will crash the whole application. In a previous project, this caused our whole API to crash randomly on production because of an async void present in the background service. So you should do not use this. Do instead this. Okay, now the second rule is use value task or task.fromResult for easy computation. This example is considered bad, wasting a thread pool thread to return something that does not need an async call. You should definitely use value task T here to avoid using an extra thread and save a minor task allocation. Value task is relatively new and not available in every case. Task.fromResult is your default. If the first one didn't work out, it will still allocate a task object on the heap, but that's still far better than wasting a whole thread. So here's an example of task.fromResult, and this is the value task example. Okay, now the third rule, use await instead of continue with. Continue with is a part of the old ways to deal with tasks. C# had tasks long before async or await, and this was the only way to deal with before. Now, because of how the state machine work and how powerful it is in capturing context, it is better to use async await instead of continue with. So here's the example. Okay, now fourth rule is task.wasting over task.delay. Task.wait async support passing down a cancellation token instead of only creating a task and filling it after a delay. This is useful when you want to add cancellation or timeout ability for async methods that inherently don't provide such capability. Okay, now the fifth rule is use new thread instead of task.run for long running process. The advantage of having a managed thread pool is to manage and reuse tasks on the fly and not waste resources. A task.run enqueue a task to the thread pool and leaves the thread to be reused for another call later on. If you are doing a long running background processes with task.run, you are effectively stealing a thread that was meant to be used for multiple asynchronous operations such as timer, callbacks, and so on. Blocking this thread will make a thread pool grow unnecessarily. A good alternative is to create a thread manually and let it live on its own. So here's the example. So number 6 rule is do not use task.result or task.wait. The problem with both, if not used correctly, is that the caller will be blocked until the asynchronous operation is executed. This uses two threads for asynchronous call instead of one, which lead to thread starvation and can cause deadlocks. This is a common anti-pattern called sync over async. So here's the example. Another very common case is timer callbacks. The default timer class in .NET has void in its signature, which make things tricky to use. Here's the issue. An alternative is to use periodic timer that supports a task instead. So number 7 rule is always pass down cancellation tokens. There are cases, especially in APIs, where passing down cancellation tokens will help you save a lot of unused threads when a cancellation occurs. Always spread this parameter all the way down to your functions. Most async calls supports it. So number 8 will be do not use action parameter alone. So here's the example. Do not use this, instead this. This is creating an async void call implicitly. One way around it is to define another overloaded accepting a function task as well to redirect async calls there instead. So here is the example. So number 9 will be flush streams before disposing. I found that this one is not known at all in the community. One thinks that disposing things to tear down everything in the most optimal way, but that might not always the case when you are using stream or stream writer. When you call a dispose for those, it will synchronously flush the buffer, blocking the current thread. If your code is IO heavy, this may result in thread starvation. An easy fix for the above is to call dispose async instead or manually call flush async to do those operations. So here's the example. Flush async. So the last rule is do not directly return tasks in async functions. This one is a bit opinionated. I have seen both and there's quite some arguments on both sides. But for the majority of the code base, one should always await underlying calls. You may gain a very minor performance benefit if you do the above by skipping a state machine, but I doubt that is even impactful or measurable for most use cases. But you lose a lot of term of debuggability and exception handling. The debugger will just hang exceptions, will entirely skip the context. There's some actual benefit of having a state machine, as those are a part of its job. By using those conventions, you will generally avoid bad things and bad code leaking away in your application. I tried to compile the most used ones I saw, but there's many more to discuss. So don't forget to subscribe our channel and hit the bell icon for latest updates. To joining our course, you can simply go to our website called startuphack.com/start-now. Thank you.